Hey guys, welcome back to another video by Roland. I'm your tutor and I'm from Think Brainwave. In this case, we'll be doing another Cartesian plane ratio. It's our second example. If you haven't seen the first and you haven't followed through all of these videos, there's an entire list to follow through. So check it out on Think Brainwave at our page. And there's a whole set of 14 odd, 15 odd videos in this subscription, I guess you could call it. Start at number 1, work your way through because it's really self-explanatory. You know, everything builds upon each other. So if you're watching from like video 5, you're missing out everything from video 4 down to 1. So make sure to go start at the beginning. It just breaks this whole trigonometry that seems like such a hectic section. It breaks it down. It's so basic. So let's start it out. We say the angle XOK is theta. This is an angle in the third quadrant where x is a point on the positive x-axis, okay? So how can it be on the positive x-axis? That doesn't really make sense. Let's think about it. Okay, well, they're referring to the x-axis as a whole as the positive x-axis, okay? This often throws people off. They always think, well, they'll often think, not always, but often would think that positive means the right-hand side of the x-axis. You know, the right-hand side of the y-axis along the x. So just realize that it's not actually referring to the positive side. It's actually just referring to the x-axis and saying that it is positive. Use it as a point 0, okay? So we have a point K. And point K, as you can see, is -5, meaning it's on the left-hand side of the y-axis along the x-axis, okay? So it's traveled leftwards. And then it's obviously traveled downwards if it's in the third quadrant. So the third quadrant means, you know, a -y. So let's determine y. We start with our step 1. Let's take it nice and slow so we can work through this thing properly, okay? We will sketch this point on our Cartesian plane. So first things first, I guess we need to draw a Cartesian plane. We need to use the correct set of axes. We need to make sure that we label our axes x and y. We need to show a correct measurement between points, as this is very important when you're doing your drawing. Okay, so we've got -5y. Okay is 13 units. That means that your point from origin to your point K is 13 units. That means that that's your R value is 13. Just reiterating that you understand it. Now remember that 13, that R value is always positive. Our x is -5. We've calculated through Pythagoras in step 2 that we get -12. Sorry for this, but we had to jump ahead. Time is of the essence. So we're just trying to show you certain basics. We all understand how to do Pythagoras by now. We understand that your y value can be plus or minus, your x value can be plus or minus, but your r value is always plus. If you aren't sure and I can't understand that why that's the case, please go watch the previous 2 videos. That explains that the r value is your radius. It starts at the origin of a circle and is always going to be positive as it moves towards the circumference. So there we go. We've got y is equal to -12 because it's moving downwards along the y-axis into the third quadrant. Our x, as mentioned before, is moving leftwards from the origin, and our r value is always going to be positive, and we found it out to be 13. So with that said, let's do another example. Let's prove the following. So let's prove that, let's prove that tan squared theta plus 1 is equal to sec squared theta. Now if you're unsure what sec is a reciprocal function. You've got cosec, sec, and cot. Cosec is for the inverse or the reciprocal of sine. Sec is the reciprocal of cos, and cot is the reciprocal of tan. So if you haven't watched the videos prior to this, you really should go watch them because everything is included from basics. You know, your basic identities, your special angles with 30, 45, and 60. We also discuss how the sine graph and the cos graph are related and how they shift in about 90 degrees, etc., etc. Just go and watch those videos. It will do you such a favor. This trigonometry will go from like a struggle section to a mastering section in 15 videos. It really breaks it down simply. Okay, so with this graph, I want to move forward now. We have x is minus 5, y is minus 12, and our r is 13. So how are we going to calculate this? We've been asked to find how tan squared theta minus 1 is equal to sec squared theta. So now that we know that we've got our x's, our y's, and our r's, what do we need to do? Well, if you look at the previous video, if not that, the previous to that video, so video maybe like 13, you'd see there's a whole little rhyme that I created, which is like shade your rear, meaning sine is y over r, cos x-rays being cos x over r, tan your exterior, tan is y over x. So we've got a minus 5 for x and a minus 12 for y. We've got an r is equal to 13. So please make sure, do not lose your signs. This is where so many students drop their signs and they create these sort of silly mistakes. You know, that's where you're going to lose 20 to 50% of your paper if you are not aware that signs are actually the most fundamental part of your test. Alright, so if you're a 60 student and you always seem to make these silly mistakes, you can easily push your mark up to an 80% student if you just watch the silly things that are actually much more important than people realize. So let's just start with this question. Okay, now that I've had my rant and we've focused, we've got tan squared theta plus 1. Okay, tan squared is tan your exterior, which means you've got y over x, which is minus 12 over minus 5, open and close your brackets, put your squared sign, and then add 1. So minus 12 over minus 5, that is 12 over 5, and then you square it, because the negative signs cancel each other out. Okay, because a minus divided by a minus is a plus, and a minus times a minus is a plus. So you've got 144 over 25 plus 25 over 25. What does that give us? That gives us 169 over 25. If we take the square root of that, we'd be able to see that we'd get a 13 over 5, but we're not going to do that. And if we are, we won't do it just yet. I'm thinking we do the right-hand side. Okay, let's do the right-hand side. It's sec squared theta. And sec squared, if you're unfamiliar with it, is the inverse of cos. So it's the same as saying 1 over cos. So if cos is cos x rays, you'd have x over r. For sec, you'd have r over x. In that case, you would square out these numbers because it's sec squared. So sec theta would be 1 over cos. Okay, let me just write it down just to clarify everything. Please make sure to go watch the previous videos. It really will clear everything up for you. So you've got sec theta is equal to 1 over cos theta. And then you've got x over r for cos theta. Now, because sec theta is the inverse, or otherwise known as the reciprocal value of cos, we flip everything. So it goes from x over r, and it becomes r over x. And that's what we've written above. So we can move forward, I think. Let's maybe move forward. So it's r over x, making it 13 over x, which is minus 5. So we say 13 over minus 5. Okay, well, let's do it in a different color so we can clarify. So it's 13 over minus 5. Okay, just making sure. Cool. And then we put the squared sign. Let's put a squared sign there. Lovely. We then have 169 over 25. So what do you see? You've actually got a positive answer there. And is that not exactly what we got on the other side? It is indeed. So on our left hand side we had 169 over 25, and subsequently on the right hand side, the one that we calculated before this, we also had 169 over 25. So we now say the left hand side is equal to the right hand side. And just to clarify, this is now the end of the grade 10 trig videos. So if you are still unclear about certain things, please make sure to go and start from the beginning of this video series and make sure that you understand everything. So now what we say is we've got tan squared theta plus 1 is equal to sec squared theta. Easy game.